Hi everyone. In our previous lecture, we discussed about the phenols and we had an introduction about of the phenols of this particular group of organic compounds, and we discussed that the phenols are those compounds in which a hydroxyl group is attached to to an aromatic system. Okay, now we are going to start the important part of this chapter, that is the preparation of phenols. Okay, and in this video we are going to discuss the preparation of phenols from the haloarenes. As we have different methods by which we can prepare the phenols, we have these different substrates that we'll be discussing one by one, and we will also discuss their mechanism and the importance of these particular methods of preparation. Okay, so looking at the preparation from haloarenes. So haloarenes is that group of organic compounds in which a halogen group, in which a halogen can be a chlorine, bromine, or iodine. These three are mostly used. So it's attached to an arene. Arenes are the is the general name given to the aromatic systems, and mostly the benzene. Okay, so from haloarenes we can prepare the phenols. Okay, and this particular process that we are going to discuss here is the Dow process. In Dow process we are taking a chlorobenzene. Okay, so chlorobenzene can be very easily prepared by electrophilic aromatic reaction of a benzene. When benzene is treated with chlorine and in presence of a catalyst, FeCl3, then we get the chlorobenzene as a product. Okay, so this is very efficient method to prepare the chlorobenzene. From this chlorobenzene, in which the chlorine is attached to benzene ring, when we react it with the aqueous sodium hydroxide, we take the aqueous sodium hydroxide at a very high temperature of about 623 Kelvin, and we give there is also a high atmospheric pressure of 320 ATP. Okay, sorry, ATM. This is the atmospheric pressure at which this reaction is done. So we have the extreme conditions, and this process is an industrial process. Dow process is an industrial process. That's by this process we can prepare the phenols on a very large scale. In this first step of the reaction, we get the sodium phenoxide as a product. Okay, sodium phenoxide as a product, which on acidification gives us the phenol. Okay, so this is a general reaction. Here we have a chlorobenzene. This chlorobenzene is treated with sodium hydroxide in aqueous form. Okay, we can also take the molten state of this sodium hydroxide, and we have very high temperature, 350 degree. This varies from 300 to 350 degree Celsius. Okay, and we have a very high pressure that we have indicated here. And in this reaction, the first product that we are getting is this sodium phenoxide, in which we have oxygen has a negative charge and the sodium has a positive charge. So this is called as this is a phenoxide ion, and this particular product that we get in the first step of the reaction is the sodium phenoxide. This is the sodium phenoxide. On acidification of this sodium phenoxide with HCl, when we take hydrochloric acid as an acid to acidify this particular product, that sodium phenoxide, we get the corresponding phenol as a product. Okay, so the first product of this reaction is of the Dow process is a phenoxide, and the second product is on acidification of this first product, we get the corresponding phenol. Okay, how this reaction goes, we'll be discussing this brief mechanism of the reaction. So what happens in the first step? There is a simple acid base reaction. The sodium hydroxide is a very strong base. When we add to the chlorobenzene, what happens? It abstracts this proton from the chlorobenzene, because this proton is more reactive. This is more acidic in comparison to any other proton of the system. Okay, we can also take this proton from this side or this side. It's one and the same thing. So it abstracts a proton. There is a acid base reaction. There is the formation of this water molecule as a result of this acid base reaction, and we get a negative charge on this carbon, because this electron pair is taken by the carbon atom. So there is a negative charge on this carbon. What happens in the next step? Because this chlorine is a good leaving group. Okay, this chlorine is a good leaving group, and all halogens are the good leaving groups, and chlorine is good among all the halogens. Okay, so this electron pair moves to this carbon, between forms a bond between these two carbons, and the chlorine leaves as Cl negative. Okay, this leaves as Cl negative. That's as a leaving group. This is a leaving group, and as a result we get a strange intermediate in the reaction. This is called as the benzene. Okay, why we are using this name benzene, YNE? Because it resembles to the, it is not the alkyne, but it resembles to the alkyne by having this triple bond. Okay, that's why we call it as benzene. So this is benzene intermediate. So in this reaction we are getting the benzene intermediate. This intermediate is very reactive, very unstable intermediate. So it quickly reacts with other hydroxide ion that is present in the reaction system. What happens, this electron pair moves to this carbon, back to this carbon, and as a result there is a formation of a positive charge on this carbon. This carbon gets the positive charge. This is simultaneously attacked by the negatively charged, that is the hydroxyl group, and as a result the OH group comes to this position. Okay, so we get this intermediate. Again, this is the carbanion intermediate we get in this step. Okay, we have a negative charge on this carbon, so this is the carbanion intermediate. What happens in the next step, this hydrogen is transferred to this position, so a proton transfer reaction takes place here. So as a result we get the sodium phenoxide, because we have Na positive ions present in this reaction system. So there is a formation of this complex in this step. Okay, so we get the sodium phenoxide. So this is the product A of the reaction. We can stop the reaction here, because this sodium phenoxide is precursor of very different organic products. We can use it as a substrate. Okay, so but we have to proceed with the reaction. So what happens, we acidify this particular sodium phenoxide, this particular product. Okay, so we acidify it with HCl. As a result we get the corresponding phenol. So this phenol we get as a product in the reaction. Okay, and this chlorine and the sodium comes out as sodium chloride, NaCl, as a byproduct. So sodium chloride comes as a byproduct, and the main product of the reaction is the phenol. So this is a simple reaction mechanism, okay, that we have shown here. So in the upcoming videos we'll be discussing the other methods of preparation of phenols, and we will also discuss the reaction mechanism of all the reactions.